This video will review all of the concepts that you need to know for the similarity and congruence test. So remember congruent triangles, there were two main things that we needed to know about congruent triangles. All corresponding angles are congruent, all corresponding sides are congruent. And we wrote that right here, okay? In order to prove that two triangles are congruent, we have to get three pieces of information. Those three pieces of information make up our postulates. And once we have proved a postulate, we have proved that two triangles are congruent. Similarity is the second topic that we covered in the unit. We learned that similar triangles are different sizes, but they are the same shape. They're different sizes because all of the corresponding sides are proportional, but they are ultimately the same shape because all of the angles are congruent. So over here, I wrote an example of two similar triangles. One is bigger, one is smaller. Corresponding angles are congruent, and corresponding sides are proportional. Okay? Similar triangles are the problems where we set up ratios in order to find the missing side lengths. If you see a similarity problem that looks like this, we always split it up into the two triangles from the picture, right? And then we label the vertices. And then up here we have our shadow problems, which is where two things being compared in size cast a shadow. We compare shadow to item, and then we compare shadow to item. In order to prove that two triangles are similar, we have two postulates. We have the angle-angle theorem, and that all three sides are proportional. If you have two triangles and you are able to prove that two of the angles are congruent, then we know that the two triangles are similar. If you can prove that all three sides are proportional, then the triangles are similar. This is just a main review of everything. Let's do some problems that might be on the test, okay? So first, this problem says, find DC if DG and JM are altitudes and triangle KJL is similar to triangle EDC. Okay. So it says that DC, we have to find the length of DC, which is right here, okay? That is what we're trying to find. The problem gives us some information. They say that DG, so DG right here, and JM are altitudes. You need to know what an altitude is in order to do the problem, right? So an altitude, if you look at a triangle, this is the base, and then this right here is going to be the height of the triangle, and it intersects the base to form two 90-degree angles. So the altitude is perpendicular to the base. Think about it. When you take the area of a triangle, or when you find the area of a triangle, you do 1/2 base times height. The height is going to be the vertical distance, right? You're not going to measure the height of somebody if they're standing on a slant. You stand up straight to get your height taken, right? So that's what an altitude is. It's the vertical distance from the base to the top of the triangle, okay? So if we know that JM and DG are altitudes, they're going to form two 90-degree angles with the base, okay? So now we know that our triangles are similar because KJL is similar to EDC. All right. Now we need to find what DC is. If we know that KJL and EDC are similar, we can make a ratio in order to find the missing sides, right? So in this triangle over here, X corresponds to side length 2. 4 corresponds to 6 minus X. We cross multiply and we get 8 equals X times 6 minus X. We distribute our X to each term in the parentheses. We get 6X minus X squared is equal to 8. Now, if you see an x squared and you're trying to solve an equation, you gotta know that it's a quadratic, okay? So I'm gonna move this 8 over to the other side of the problem. I'm gonna get 0 equals 6x minus x squared minus 8. Now, I don't know how to solve a quadratic that's in this form, so I'm gonna move it to standard form. I'm gonna move, remember, think about each thing as a puzzle piece, right? I'm gonna move the negative x squared, and the sign will follow, plus 6x minus 8. Now I have my quadratic in a recognizable, solvable form. So I have negative x squared plus 6x minus 8. I'm going to divide the whole thing by negative 1 in order to get rid of that negative x squared. And I'm going to get x squared plus, x squared minus 6x plus 8. Now I factor that. Remember how we factor? A times c goes up top, b term goes on the bottom. Okay, so a times c goes up here. A is 1, c is 8. We have 8 up there. The b term is negative 6. Now in this circle here, we're trying to find the factors of AC that add up to negative 6. So that is going to be negative 4 and negative 2. And then remember the bottom part is just going to be the same. Okay? So now I split my b term. I have x squared minus 4x minus 2x plus 8. I add my parentheses, right? And I get x minus 4. I get negative 2. X minus 4. And my two factors become x minus 4 and x minus 2. Now I solve, I get x minus 4 equals 0, x minus 2 equals 0, I get x equals 4, x equals 2. Now let's think about these problems, right? Let's test these x values in the equations. Let's say we put 4 up here, right? Let's say we put 4 up here. So now x equals 4. I'm going to put 4 for x. So now I get 2 as my distance over here, and I get 4 as my distance over here. Okay, that could work. None of them are negative. It's fine. Let's try 2. This becomes 2. 6 minus 2 gives me 4. We have 2 and 4, 2 and 4. Oh, that makes congruent triangles. 2 congruent triangles. Our triangles should not be congruent. They are similar. Therefore, 2 does not work. 4 works. 4 is the answer. This problem here. Find FB if SA and FB are altitudes and RST is similar to EFG. Okay, SA and FB are altitudes. Remember, this is a word that we just went over in the last problem. Altitudes intersect the base at 90 degrees, and they are the height of the triangle. Okay, good. Now we look at the problem, right? RST, this triangle here, is similar to this triangle here. So now we can set up a ratio in order to solve for x. So let's start with the first triangle, RST. X will correspond to 5. Everything is very small. Okay, x will correspond to 5. And 2 will correspond to 7 minus x. Okay, cross multiply. We get 10 equals x times 7 minus x. We get 10 equals 7x minus x squared. I see that this is a quadratic. I'm going to get this 10 out of this side. We get 7x minus x squared minus 10 equals 0. Okay? I need this x squared to be in the front because I need this to be in standard form. So I'm going to reorganize my terms, and I will get negative x squared plus 7x minus 10. I'm going to divide the whole thing by negative 1 to get rid of that negative x squared. Divide both sides by negative 1, and I get x squared minus 7x plus 10. Let's factor this. I put a times c up top. A is 1, c is 10. 10 goes up top. B is negative 7. What are the factors of a times c that add up to negative 7? And they are negative 5 and negative 2. This moves down here. This is what our b term is split up into. We split the b term. We get x squared minus 5x minus 2x plus 10. Add my parentheses. I get x minus 5. Over here I get negative 2, x minus 5. My new factors become x minus 5, x minus 2. Set them both equal to 0. X equals 5, x equals 2. I'm going to plug these back into the equation, and we find that when I plug 5 in, I get 2 over here, 2 over here, 5 over here, 5 over here. They're congruent triangles. 5 does not work. Let's try with 2. I plug 2 in up here, and I get 5 and 5, 2 and 2. 2 works. My answer is 2. Let's try this problem here. Okay, we have a given. DL right here, bisects. Bisect is a juicy word. Remember what bisect means. It means cut in half. Cut in half. BN. So it cuts this line here, BN, in half. Therefore, it makes 2 equal sides. Okay? Angle XLN right here, is congruent to angle XDB. Remember, the letter in the middle is the vertex. Okay? That's how we read angles. That's how we write angles. Gotta know that by now. There we go. Okay, now we have done the first step. We put the given into the figure. First step, put the given into the figure. Now the next step, step 2, is we pick our postulate. Okay? So let's see, here we have side and an angle. Okay, so we need another piece of information. Well, we know we're trying to prove that LN, this side here, is congruent to DB. So we're working with this triangle here and this triangle here. So we need to prove that those two triangles are congruent. If we have one angle in each one equal and one side equal on each one, let's prove that these two angles here are congruent because they're vertical angles. Okay? So let's pick our postulate. We have angle, angle, side. Okay, angle, angle, side. Angle, angle, side. That is our postulate. Let's fill out our proof, statements, reasons, and then we put our postulate over here, right? Angle, angle, side. This becomes our to-do list. So the first angle that we know is congruent. Angle XLN is congruent to angle XDB. How do we know this? Given. The next angle that we know, angle LXN, LXN is congruent to angle BXD, BXD. How do we know that? Vertical angles. Finally, the side that we want to prove is that BX is congruent to XN. side BX is congruent to side XN. And we know that because DL bisects BN. And when you bisect something, you cut it in half. So we know that it creates two equal sides. So we have now proven that triangle BXD is congruent to triangle LXN. And we know that because our postulate that we picked, angle, angle, side, is congruent to angle, angle, side. So now that we've proven the two triangles are congruent, we can prove that LN is congruent to DB. So LN is congruent to DB. Why? Because corresponding parts of congruent triangles are congruent. Okay? Let's do one more. Write a proof. Okay, so first thing we do, read our given, put it in the figure. Our given angle NOM, this angle here, is congruent to angle POR, this angle here. And N is perpendicular, hold on, let's do a different color. And M is perpendicular to MR. To MR. What does perpendicular mean? This is 90. PR is perpendicular to MR. What does that mean? This angle here is 90. And then they tell us that NM, side NM, is congruent to side PR. Now we have to pick our postulate. We have put the given into the figure. Now we pick our postulate. We have a side here, angle here, and an angle here. Let's do side, angle, angle. Over here we have side, angle, angle. Is that a postulate? Yes. Let's prove it. So remember, our postulate becomes our to-do list. We put that over here, right? Side, angle, angle. The first sides that we want to prove are congruent. Let's do NM is congruent to PR. How do we know that? Given. The next thing we have to prove is angle. We know that angle NMO is congruent to angle PRO. And the reason is NM is perpendicular to MR. PR is perpendicular to MR. Those are given, and they're both 90 degrees. The final angle that we want to prove is that angle NOM is congruent to angle POR. And the reason for that is that is given. Now we have proven that triangle NMO is congruent to triangle PRO. And the reason is always our postulate that we picked. Side angle angle is congruent to side angle angle. Now we can prove this thing up here, right? Because corresponding parts of congruent triangles are congruent. Or you can just write triangle NMO is congruent to triangle PRO, whatever you want to write. Either this or the thing we wrote last time, which was corresponding parts of congruent triangles are congruent.